There are a number of interpretations of quantum mechanics. Humans think quantum mechanics is in need of an interpretation. All interpretations so far have been debatable and debated. I know of no interpretation that is universally accepted. Here is not the place to discuss them all. The most common one, and the one that was probably there first, is the Copenhagen interpretation, promoted among others by Niels Bohr. This interpretation is likely the simplest of them all. It basically says that when we test a model of the world, quantum mechanical calculations work for the particle and wave constructions we think real. We should just do the calculations and be okay with the fact that in the really small realm, things are not what they are in the realm of macro stuff. This short video is about showing how this interpretation isn't needed. The Copenhagen interpretation, formulated by physicists such as Niels Bohr and Werner Heisenberg, is one of the earliest and most influential interpretations of quantum mechanics. As a student, I grew up and never came to terms with it, but accepted it as the best interpretation around. If you describe reality by using particles, waves, their duality, and quantum mechanics, then three characteristics are relevant to the Copenhagen interpretation: superposition of states, wave function collapse, and the probabilistic nature of the outcomes of experiments. The concept of wave function collapse is the most controversial and a key element of the Copenhagen interpretation of quantum mechanics. The measurement process has a central role in the development of reality and hints at a special role for the observer. There is no clear reason why the moment of measurement is breaking the symmetry of the possible outcomes of the measurement. In my opinion, this interpretation, or any other for that matter, is unnecessary, unwanted, and even misleading or perhaps nonsense. I suspect that nature is space-time capital, as was introduced in an earlier movie. And this explains why the human perspective of introducing particles and the particle-wave duality gives rise to the probabilistic nature of the measurement process and the limitations of the scientific method. Particles and the particle-wave duality are just not there in reality. They live in the world of the human perspective on reality. In other words, quantum mechanics is not in need of any interpretation, because it is itself an interpretation of space-time capital. Niels Bohr was right when he supposedly said, "Shut up and calculate," whether he ever said that or not. From the human perspective, that is all we can do to grasp our perspective. Just calculate with a useful tool. To decide the question if we need any interpretation of quantum mechanics, we have to do the research I propose in my book, that you can find in the description below.